reference. I'm just going to continue talking about what Professor talked about. I'm going to talk about halls a little bit. So what is a hall? A hall is basically the watertight uh, body of a ship. There are all different kinds of halls, and there was a very short video that I found that I thought it explained it pretty well. So let's see if we can flash it here.
Types of hulls. Flat bottom boat. They are generally less expensive to build and have a shallow draft. They can get on plane easily, but unless the water surface is perfectly calm, the ride can be rough because the flat bottom hits each wave. They are less stable and require careful balancing of the cargo and crew. V-bottom boat. The V-bottom rough waters, but needs more power to achieve the same speed. Many runabouts use the V-bottom design. Round bottom boat. It moves easily through the water, especially at slow speeds, but tends to roll unless fitted with a deep keel or stabilizers. Many trawlers, canoes, and sailboats have round bottoms. Multi-hull boat. Catamarans, trimarans, pontoon boats, and some houseboats have a multi-hull design. The wide stance gives greater stability. Each of the hulls may have any of the bottom designs described above.
Yeah, those were different kinds of halls. So in the next few lectures, we're gonna talk about different kinds of coefficients, and in those coefficients, we're gonna have a lot to talk about displacement. I'm sure you guys know about it. I just remind you. Displacement is basically when you put an object inside a fluid and then you immerse it. The amount of the volume of the water or any kind of fluid that pops out as you immerse the object in that fluid, it's basically called the displacement. And we're going to use this in the next few lectures. So the very first coefficient that we have is the coefficient of fineness of water plane area, uh, which is basically the water plane area divided by the area of the rectangular that has basically the same length and same breadth. I'll get back to this, and you can actually see the picture here. I'll get back to this because it can get a little bit confusing when I introduce another coefficient later. Um, we're so I'm going to talk about also the block coefficient. Block coefficient basically represent the bulkiness, the fullness um, of the hull, and it's the ratio of the volume of the displacement that we just talked about to the volume of the rectangular of the block. So in the previous slide, if you remember, I talked about almost the same thing. But it was the area. So the difference between this and the previous one is that in this one we talk about the volume, but in the previous coefficient we're talking about the area. And those ships that they have high block coefficient, it means they will have lower speed, but they can have basically higher cargo, and vice versa if they have lower coefficient of bulkiness. So basically, the coefficient of bulkiness concerns with the volume, but the coefficient of fineness of water plane area is concerned with the area. And this is basically the shape of it, as you can see. So you get the you get the rectangular, and then it has the same length, same width, and same height as the ship. Um, another coefficient that we have is called the midship section coefficient, um, which the midship coefficient basically it's also similar to the previous coefficient, except that here we take the area of the ship that is actually submerged in the water. So in the in the first slide here, we take the whole area. Uh, in the block coefficient, we take the volume, and in the midship section coefficient, we basically take the area of the ship that is actually submerged in the water. So that's the differences between this. Did you guys understand all of it? The midship coefficient, and the bulk coefficient, and the water plane area. I'll summarize all of them at the end. And I mean, not I. Somebody has summarized it at the end in a video. Um, yeah. Just to wrap it up, because we might need it for the future slides. So for the midship, it's the area that is submerged. For the bulk, it's the volume, and for the water plane area, it's the area of the ship. Um, so there is another coefficient. Don't ask me why they have so many. I don't know. But then there's another coefficient. It's prismatic coefficient. It's again similar to all the previous coefficients, except that here, instead of rectangular, they are using a prismatic area, and here it's not volume. Um, the only coefficient that is concerned with the volume is the block coefficient. The rest of them basically are concerned with the area, and this one, instead of being concerned with the area of the rectangular, is concerned with the area of the prism. So you can basically see the volume, see the formula there, and so the Freud number is basically the ratio of the flow of inertia to external field. As you can see, you can get it by the formula here. There's a very good video on YouTube with a guy who is actually showing the Freud number in his kitchen sink. I wanted to put it up, but the sort of the voice is terrible, so I just didn't put it. So if you're interested, later on you can just look out for Freud number in kitchen sink, and it's a pretty fun video to watch. So I talked about the displacement, and then there's another ratio. It's called displacement to length ratio, and this one you can think about it as basically fatness versus slimness, and it predicts speed and power. You can even draw an analogy, let's say, to humans. Humans, we also, if you take the displacement as a whole volume and then length at the height of a person, you can also get the same concept of fatness and slimness. And in ships, it tries to basically predict speed and power. It's a non-dimensional expression basically of how heavy or how light a boat is. And it's calculated by dividing a boat's displacement by 1/100th of the waterline's length cubed. So I wanted to just put simply what hydrostatic curves are, or what they actually what sort of information you can extract from them. Hydrostatic curves basically they give you information about the buoyancy, about displacement, and center of flotation. And one of those hydrostatic curves is the Boyne curves, as you can actually see it down here. And there are two more terminologies that we're going to cover. One is the LCB and the other one is LCF. LCB is basically the longitudinal center of buoyancy. It's the center of the immersed volume. And if you remember from the previous slides, in the immersed, we use the midship plane. And then we have the LCF, which is defined as the longitudinal center. So LCF is basically the center of the water plane. And what basically connects these LCB to LCF is through the trimming moment. Trimming moment, for those of you who have studied anything related to mechanical engineering, is basically the torque. So it's the torque that you calculate around the LCF. And so there is a long video that I have picked a very short part of it that basically summarizes what I just explained. So it's like a 2 or 3 minute summary of everything that I just explained.
Block coefficient is a very important one in terms of for how you can compare different ships. Even if it's the same kind of ship, you can compare them to block coefficient. To describe the overall performance of the hull, you see here, so it's total volume that this actually takes up based on length times speed times drag. But then you compare that to how much latitude takes up, which is the volume again, the length is usually the length of the water line. For a destroyer that is primarily concerned with speed and performance, it's going to have a finer hull. It will have a lower block coefficient. But for a very large tank, which is trying to haul a bunch of cargo, it's going to have a much fuller hull, which means its block coefficient is higher. Here, this is one number, like if you compare hulls that are very complicated and may look very differently. You can boil it down to a number that you can really wrap your head around.
So that was the sorry, that was the block coefficient that I wanted everybody to understand. So the three takeaways that I want you guys to know: one is the block coefficient, one is the mid shift, and the other one is the area. Did you guys understand all of it, or anyone has any questions? All right, thank you.